Hi, welcome to Deep Casing Tools' first attempt at a webinar. We thought it might be interesting to have a chat today with myself, Steve Kent. I'm Executive Chairman at Deep Casing Tools, and David Stephenson. David, can you maybe introduce yourself quickly?
Absolutely. Thanks, Steve. I'm David Stephenson. I'm the CEO of Deep Casing Tools. Been with the company for a little over 4 years now. Excited to be here. Like you said, first webinar, so fingers crossed.
Well, let's hope we can keep people interested and engaged. We'll see how we get on. The first thing we should do is just give a brief introduction to Deep Casing Tools, because we're aware that some people joining us might not know the business very well. So I guess if we're going to sum up Deep Casing Tools, who are we, David, and what do we do?
We are a small 20-person private equity-owned technology development business. Been around for about 10 years. Historically, our focus has been very much on target depth technology, turbine-driven Reamer shoes aimed at getting completions, liners, casings, etc. to depth. Over the last 3 or 4 years, we've diversified our product portfolio and are going into the P&A space and a few other areas. Our ethos is about simple, sustainable technology and innovation. And I'd say, you know, and it's maybe a little bit of a cliche, but we're not trying to reinvent the wheel. We're just trying to make the wheel a little better. So there's lots of technologies that have been around for a long time in our industry. They're known and they're trusted, but they could be a little better and a little more predictable. And that's something that we set about trying to achieve through our technology development. So. Yeah,
and that makes sense. We should also mention that if you want to check us out on the website, www.deepcasingtools.com, we've got an overview of who we are, what we do, our technologies, our bread and butter technologies, as well as the ones that are in development and very soon to be commercialized. Thinking about that, you know, you talk about target depth technology, and I guess there was a reason why the turbine tools helping us to get liners, completions to depth, casing strings to depth, having that drill through capability on our some of our on our turbine tools, particularly the turbo caser. You know, we jump into technology, which is great, but actually the reason for existing is often to reduce non-productive time, right? Because we see non-productive time in the business as being a huge issue. And I think sometimes our peers get jaded with the term non-productive time because we've been talking about it in our industry for so long. But our original turbine tools, I guess the reason for existing with that is to look at non-productive time because it's so crucial in the industry. Would that be a fair point?
Yeah, I think it is absolutely a fair point, and I think there's lots of facets to non-productive time, and you know, our industry is, like a lot, is financials and profit and revenues at the back of it, and non-productive time obviously hurts that. It's becoming more and more important. I think it's something we've always had an eye on. I think it's becoming a lot more of the moment on carbon emission reduction. You know, while we can't be desperately part of an energy transition, we are at the moment an oil and gas related business. We can certainly do everything within our power to reduce carbon emissions. And fortunately, along with reducing carbon emissions, typically comes reducing non-productive time. So, you know, we set out 10 years ago, before my time with the company, looking to address non-productive time. And as wells typically get more complicated, longer, you have much more expensive completions, more complex completions, it naturally becomes more difficult TD sections to get completions to depth. So that was identified by the founders of deep casing tools. I think probably 2009, 2010. And one of the technologies that you mentioned was the Turborunner. It was identified at the time that if you could have something that went on the end of a completion or a liner, a final string in a well, as those wells get longer and longer and more deviated.
And was that the first product that was developed in the business?
Yeah, so the Turborunner was the first product, and the idea was to have a tool that you put on the end of the string that you do not need to rotate the string from surface. And the reason for not rotating the string from surface is it's becoming impossible. As these wells get longer and more deviated, your torque and drag issues become more and more. So the idea was to have a turbine-driven shoe that goes on the end, and all you do is pump through the string and you rotate a Reamer shoe on the end. And the Turborunner was born at that point. And we've sold over 300, ran close to 300 with a fantastic success rate for that tool. The next evolution of that tool was obviously if we could have that tool on an intermediate string in a well that you then need to drill out and drill ahead, is it possible to do the same? And the Turbo Caser was born at that point. So the Turbo Caser is effectively a Turborunner, a turbine-driven Reamer shoe, but it has a pass-through and drill-through ID. So you can set a casing, cement it in place, pick up your next drill bit and drill ahead without need for a dedicated trip, without any milling or anything. You just drill straight ahead.
So the focusing back on the MPT issue, I guess with the Turborunner, it was initially getting liners, long strings, completions to bottom. And I guess it started off with completions that you really can't afford to rotate, sand screens, intelligent completions. You've got to have something that you're able to activate from surface without rotating the whole string. Can you just give us I know there's some cool videos actually on the website. Again, www.deepcasingtools.com. Look at the videos, some cool animations which are useful. If we talk about the operation of let's stick with the Turborunner. Simply put it on the bottom of the string, run it in the well, pump through it. It spins the shoe and helps you get to bottom.
Pretty much, yeah. And like you say, there's some fantastic animations. If you look on YouTube as well, there's information out there. There's quite a lot of case histories on the website. One recent case history is we did a 4-well campaign in Nigeria. We were actually working in partnership with the completion company. So it was a brand new single trip RFID controlled completion. As you know, or anyone listening knows, the importance of getting a completion on depth where you planned it, when you have swell packers and inflow control devices and all sorts of different compartments. It's absolutely critical to get it on depth. So we ran 4 of our 7-inch Turborunners in 8.5-inch hole. So it's exactly like you say, Steve. You pick up the Turborunner on the bottom. You'll typically have your float equipment above our tool, standard off-the-shelf float equipment. We'll cut a thread to suit whatever you have above, and then you'll typically have the completion. Obviously, if it's a sand screen or an open completion, you need the flow to get to the TD, to the toe to our tool, so you'll run an inner string. We do that all the time. It's not complicated at all. On one of the four wells, in fact, the first well in the 4-well campaign, they actually got stuck off bottom. They got stuck about 20 meters off bottom. You don't need to turn on or pump through the Turborunner until you need it. They got stuck off bottom, started pumping, and managed to ream that completion to depth. And I heard that the company rep, as they were leaving the rig floor, said, "Thank goodness we ran that Turborunner. Otherwise, you're either setting off bottom, which obviously reduces production, your return on investment, or heaven forbid, you're pulling the whole lot back out of the hole, laying down clean-up trips." And I think on that one well, we were told we saved them 72 hours. So 3 days of rig time, which goes back to the MPT as we started the discussion. It goes back to carbon emission reduction, etc., etc. So very, very valuable, I think.
But was that what kind of rig was that? Was that a deep water?
Yeah, deep water,
floater?
Offshore. Yeah. So, you know, from an emissions perspective, that rig is probably producing 300 metric tons of carbon dioxide a day. So obviously reducing that has a huge impact as well.
Yeah, absolutely. So if we go back to that, we take that Snepco, I believe it was a Snepco installation.
Yeah.
Can you talk a bit about how we interact with the customer there on day one? You know, what do we do from an engineering perspective to make sure that we've got the right application for our equipment and how that's covered off, and what do we do? What are we capable of?
We're very capable. I mean, I think we're one of the few, maybe one of the only small service companies that has an in-house well engineer. So on our in our team, we have a gentleman called David Charles, who his background initially was actually drill bits for Baker, but then the last 15 years or so, he's been a well engineer and senior well engineer for various people. His last well engineering role was actually for ADNOC in the UAE. So he comes to us with a huge amount of experience. You know, I always say, as a service company, we like to think we know what the customer, the operator wants, but I'm not convinced we do, to be honest. So having somebody in our ranks in that role, they do know what the customer wants, and he has the ability of planning, doing the right thing. We do all the torque and drag, all the hydraulic modelling. I think he has the experience that I've had with David interacting with a customer. I kind of say it's a bit like a fatherly figure. He puts a warm arm around your shoulder, and you know when he says something that he's telling the truth, and it's correct. So we've got a fantastic capability in there, and that's involved in that Snepco example from day one. Not just with Snepco, but with Weatherford, who were the completion supplier as well. So it's very much a team event. You know, everyone works together, double checks, torque and drag, all that sort of stuff. So very in-depth, very thorough planning, and that leads to success, reaching TD, minimising MPT, which again we started off speaking about.
We've had, you know, we talked about several hundred installations. I know that there was a campaign for Equinor at Gulfax, where we had a 6-well campaign, I believe. Do you want to talk a bit about the background of that, how that came about? Even though were they having problems before? What we did, how we interacted with them, what the results of that were?
Yeah, that was actually our turbo caser, so that was effectively the evolution of the Turborunner. So it was an intermediate string. It was a 7-inch intermediate cemented liner. They have a lot of problems. They've got notoriously unstable shales and coal seams in the Gulfax, and I think the Osberg field. And they've just had hellish problems trying to get that 7-inch liner to depth, often having to pull back out a hole, often having to under-ream the hole ahead, wiper trips, all sorts of stuff. So one of their drilling engineers actually was aware of deep casing tools, was aware of the technology we were developing and approached us, and we obviously worked with them. And like you said, yeah, we ran 6 of our 7-inch turbo casers between the two fields, the Gulfax and the Osberg field, and got every 7-inch liner to reach TD. We didn't ream on every liner, but there was one of the wells that we reamed constantly for 21 hours. So I think that shows, well, it shows that there was a restriction, an organic obstruction in the way that was, you know, a standard shoe of any type would highly unlikely to have got past that. With our tool, ream for 21 hours. I think it shows the durability and the robustness of the tool, that you can sit with weight on bit reaming for 21 hours. And you know, you can sit and say, well, that's 21 hours of lost rig time, but the alternative would have been pulling the string back out of the hole, wiper trips, maybe even hole opening, and then going back again. So I think we saved again, it was between 3 and 4 days on that. So for the sake of the cost of the tool and 21 hours of reaming, you actually save 3 or 4 days offshore, Norway, $300,000 a day, perhaps, something like that.
And just to be clear, the difference between the Turborunner and the Turbo Caser is that the Turborunner always goes on the last string going in the well or the completion string, and the Turbo Caser has got a pass through capability which will go on typically an intermediate string. So with those applications that we've just been talking about, 7-inch Turbo Caser, then they were going to go and drill that out, and actually their completion string would have been, I guess, 5.5-inch liner.
That's right, yeah. So we set the 7-inch Turbo Caser on a 7-inch line at an 8.5-inch hole. They drilled out with 6 1/8-inch bit. The only part of our Turbo Caser you drill out, there's an aluminium burst disc at the top, and the Reamer shoe, which is a phosphor bronze material, and it takes about 15 minutes. So it's a very, very straightforward process. 15 minutes with a PDC, a little longer with a tricone. We actually drilled one out last week. We drilled out a 9 5/8 Turbo Caser for ADNOC offshore UAE. It took about 45 minutes because they wanted to go with a tricone bit just because of the formation in the next section. But yeah, that's it. So drilled out with a 6 1/8-inch bit on those wells, and then ran a completion straight through. So no loss of hole size, no dedicated reaming trips or anything at all. Very standard.
Yeah. And when we think about MPT, of course, we can build up a very difficult picture where you might have an operator who, in a worst case scenario, actually may end up sidetracking because they can't get through the whatever lithology they're trying to get through. But in the worst case, I guess there's there's actually going to lose the well.
Yeah, absolutely.
So have we? I guess we've seen that when we've been looking at customer issues. No customer wants to raise a flag and say, "Look at us over here, we've lost this well." But we must have seen that in the past.
We've seen it. We've seen lots of sidetracks in the past. We've seen people come to us saying, "We had to sidetrack the last well. We'll run your tool." Yeah, I mean, out of between Turborunner and Turbo Caser, we've sold almost 600 tools. There are a handful in inventory around the world, but we've run over 500 of those tools. And our customer base is hugely varied. We go from, it can honestly go from a phone call on a Friday afternoon, we're in a world of hurt, we got stuck, we're back out, we need a tool, and we're worried that we're going to have to sidetrack or lose the well, to repeat customers. So Saudi Aramco in the Middle East, we've been running tools for a long time. We've got long-form service contracts, corporate purchase agreements. We hold tools in country. We have people in country, and the drilling engineer or completion engineer hits a drop-down box on his laptop, and boom, we mobilize a tool. So they can see the value. And you've got guys like Aramco, for example, or even the Equinor Gulfax example. They didn't have to ream or turn on and ream every tool to TD, but the one out of the 6 that they did have to use more than pays for the other 5. And that's a lot of our shells. Another example, in fact, we've got a tool on a well. I think it's the Gannet field in the North Sea. We were running tools for Brunei Shell Petroleum and for Shell Malaysia already this year, and they're at a point where they'll just run the tools. They've got a 4-well campaign. They'll typically stick a Turborunner on the end. If they don't get stuck and don't need to use it, it's not a big deal. It's an insurance, isn't it? It's there if you need it, and it's a cliche, but you don't know what you don't know. You only find out you're going to get stuck in a hole typically when you get stuck in a hole in a lot of occasions. So yeah.
And I guess when we look at our operations and where the customers are focused. And I think in these these days of COVID, we haven't mentioned COVID yet on the call, but here we are, still in it. Oil price crash early end of Q1 2020, rebounding oil price now, but our customers are still mostly going through, I guess, ratification of their own organizations, and an extreme focus on cost measures. It seems to me like the turbo tools really have got a significant value, because for the cost of the tool versus the cost of the MPT, it seems to make sense. However, we wouldn't be proponents of using a tool on every single well. But do you think there's a reason why, with the company's been successful, but wants to be more successful? What do you think are the reasons that customers look at us and say, well, actually, I'm not quite sure. It's is it a high cost insurance policy, or do you feel like we don't do a good enough job demonstrating the value that we bring to the customer? How do you think that's perceived?
It's a very good question, and it's nice to hear the word value used rather than cost, because quite often people just look at cost. It's hugely varied. I spent a long time living in the Middle East and in Southeast Asia. I'm now based in Aberdeen, and I've seen the costs of different wells and the costs, different spread rates, and you've got to kind of pick your battles. I remember sitting in BP's office in Muscat in Oman a few years ago, and I presented the turbo caser, and they absolutely loved it. They have problems getting every single 7-inch liner to depth. They have problems in, it was 9 5/8, a 9 5/8 casing inside 12 1/4-inch hole. And I was sitting there thinking, oh, this is good. This is a perfect application for a turbo caser. And then the guy said, sometimes we have to fight for 2 days to get the casing to depth. And I know our spread rate for PDO or BP in Oman's about $25,000 a day. So I know it's not worth me telling him he should buy a turbo caser. But there are other areas that I've mentioned, the Equinor offshore, they see the value in the tool. They don't just look at the cost, because if you look at the cost compared to a standard off-the-shelf Reamer shoe that you have to rotate the entire string, obviously you're not comparing apples with apples, so it's very, very different. But when you get into the value creation and show them what it's worth, it makes a big, big difference. But the market is, I think in our industry, it's always the highest of highs and lowest of lows. And I often wish we could take the top off the peaks and the bottom out the troughs and have somewhere in between. But I'm not quite sure we're ever going to get to that position. So we do what we can. It is difficult in times like we've seen 2020. You mentioned we are coming out of a horrible oil price crash, I guess. A reduction in demand. I'm not sure that demand has desperately changed, but I think the supply has dropped a huge amount because of rig count dropping and things getting deferred. But at the same time, if you're drilling a well with a lower oil price, there's less fat, and every penny is important, every dollar is important. So reaching TD as planned, reducing NPT is a good thing. And we believe that between the technology and the people we have on board, we believe we can prove that we can do that. We've got a track record that says we can do that. We've got repeat customers that say we can do that. So we believe that we're in a strong position with all those different things that are involved.
Yeah, it's a good point. And I kind of go back to the start of the conversation, David, where we're talking about MPT again, and we've been talking about, I've been in the industry for 34 years. Goodness me, 34 years. And, we've been talking about MPT forever. what is it about MPT that you think operators look at and think, why do we all struggle with it so much? Is it about poor risk management? Is it about project preparation? What's your take on it? And I'm focused here on deep casing tools.
Yeah.
And how do you think that works as a process?
I think for me, there's one word that always sticks out, and it's predictability. If you could predict everything that happened, the world would be wonderful. We'd never have any problems. Unfortunately, we can't. You mentioned COVID. Nobody predicted COVID, with the exception of a few people that believe that some did. I'm not convinced anyone predicted it. We are where we are. We see the oil price to and fro. Some people maybe can predict it. I certainly can't. So if we can predict things going forward, it makes life an awful lot easier. And while we don't have a crystal ball, we can help with predictability. And I'll use an example of, fishing and pulling casing out of wells has been around forever. We've been doing it for decades and decades, and it's still around. People are still cutting and pulling casing. Arguably, nothing revolutionary has come along because we're still doing it. And if you can't cut and pull, you mill. It's a horrible thing to do, but it's one of the eventualities of it all. If you can predict where you can cut and pull a casing, how much casing you can pull out, it makes your life an awful lot easier. So that's one of the things that we focus on. The Turborunner turbo caser is increasing the ability to predict the chances of getting to TD, I guess, or where to set your TD. Our casing cement breaker, which is a new technology, it's still a prototype tool. We've done one field trial for Equinor in the Norwegian North Sea, and we're not trying to, going back to not reinventing the wheel. We're not coming along and saying we're going to turn up with a magic pill that will P&A a well and shut it all in. But we're saying you're currently cutting and pulling, you're having a lot of problems cutting and pulling, therefore you're having to cut and pull really short lengths. But we can change that. We can make it more predictable. You can predict what length you'll be able to pull and do it reliably. And the same with perf and wash. Again, perf and wash, I think, is a fantastic technology, but it's becoming a little more unpredictable. If you've got a good cement job, you can't perf and wash. We know our casing cement breaker can turn a good cement job into a bad cement job by breaking the bond between the casing and the cement, breaking down the structure of the cement, and then can allow you to go about your perf and wash. So
predictability is it's a good phrase, and anybody who's interested in casing cement breaker and how to break up the cement in a fishing or a P&A type operation, they can have a look at the tool on our website, right, and have a look at that. But it goes back to MPT again.
Sorry to interrupt. One other thing I did want to mention is technology. There are some fantastic organisations around promoting and funding. The Oil and Gas Technology Centre, or OGTC in Aberdeen, is a prime example of that. They're allowing small companies like us to develop technologies that we perhaps couldn't have afforded to. And they're also bringing industry partners. Total's one of our industry partners for the development of so they are bringing technology to the market. But I still think our industry, as much as I love it, is still way behind other aerospace and other industries that are out there. We are a little bit lagging. I think we're trying to catch up. But I still think we're a little behind. So the development of technology, I think, is a big thing. And it's quite exciting to see lots of little technology companies doing that. Hopefully it continues. And
I'm sure that that's got to tie in, David, to the industry's environmental footprint, because we see very recently that UK government initiatives for decarbonisation of our industry, some ambitious targets there. And actually, when you talk about MPT, there's definitely a monetary cost involved with that, but there's also, of course, 2 days of rig time has got a massive impact on emissions. So, I think we've all got a responsibility to provide technologies that can not just save time and therefore money, but also save on emissions. And I think that's something that we need to understand our impact on that as a business more closely. I know we've started to do that, but we need to do it more closely. And it's probably a subject for another webinar. So I think right now we should try and wrap this up, David. I think it's been an interesting chat. What we'll do, I guess, is we'll open up to questions now, and let's see if we've got an audience who wants to ask a question.
I haven't bored them off yet.
Yeah. Okay. So let's open up for questions. Okay, I've got a panel here that I can see on my screen, just so everyone knows the questions have been popping up during the webinar. So thanks really for everybody who's posed a question up there. There are some common questions on there, David, which we'll probably just start off with. One is about the risk of accidentally sidetracking the well while the turbo case is on, and I think that's a common question, right? So maybe good to answer that.
Yeah, I think it's applicable to both Turbo Caser and Turborunner. They're both very similar tools, and it is a question we get asked a lot. We're to date, we're 100% confident we've never ever had the issue. I mentioned earlier we've run around 500 tools, and we know we've never sidetracked. And it's really the design of the tool. The tool has a long, non-aggressive style nose that is designed specifically for reaming and not for drilling. There is also the nature of a turbine is a high-speed, low-torque motor. And again, the tool's much more suitable for reaming organic obstructions, ledges, restrictions, etc., rather than actually drilling in.
I guess it's not designed to drill, right?
Yeah, if we were to simply set the tool on bottom and try and drill a new hole, it doesn't really go anywhere. The ROP would be microscopic. So it's just the nature of the tool, the turbine, the design of the Reamer shoe, etc., that we know it's not.
Yeah, so high speed, low torque, rather than high torque, low speed that you get in drilling.
Which again it's not only good for reaming, but if you're running completions, you don't want a tool that generates high torque, that generates high reactive torque, that can damage anything behind it. So again, it's very suitable for that as well.
Good point. Okay, we'll try and whiz through some of these. So another interesting question: what are the key performance indicators from offset wells that will show the value of the technology when analysing an application? So I've been looking at that question for the last 10 or so minutes. So I just had in mind, the runs that we do with Aramco, for instance.
Yeah.
We have a good indication of which fields cause problems, which lithology causes problems, and what are the key performance indicators. So we're looking for flat time or non-productive time that in those cases have been happening in offset wells that we're reducing, right?
Absolutely. Yeah, I think you've answered the question, Steve, and I talked about some of the experiences we've had with Equinor or Aramco. I guess for me, the simple answer is customers like Aramco run the tool because they know from offset wells that they're going to have problems, be it a sloughing shale in an intermediate string or a fractured reservoir lower down. They know they're going to have issues, and they'll typically run a tool. I'm sure we could go into a lot of science and come up with some more proof, but for me, the proof's in the pudding. They run the tools because they have problems in offset wells. So.
Yeah. Have we got any data that shows the current status on the amount of NPT suffered with casing and or liner installations?
I thought I asked you find some easy questions for me.
I just like putting you on the spot here. It's a great question.
Yeah, I mean, our case histories. So if you go to www.deepcasingtools.com and you look, you find case histories on there. There's a whole raft of different case histories, and what they typically show, they demonstrate time savings, which is MPT saving, I guess, which is the theme, cost saving, etc. So there's a handful of examples on the website. We have hundreds of examples. We have a very, very, very detailed operations register where we gather as much information as we can. There are jobs that have been run, especially this last 12 months or so, without one of our guys on the rig site. So we don't always get data. So I think rather than me trying to quote some examples, probably if somebody...
Have a look at the data sheets on the website.
Have a look at the data sheet.
And then we can have the conversation.
Yeah, there's an email address on the website to get in touch, or you can email at david@deepcasingtools.com.
All right. Moving on, we'll just try and keep these brief. Do we have any any case histories with Shell?
Lots, yes. I mean, I mentioned earlier on, we actually have a tool offshore in the North Sea, a 7-inch Turborunner with Shell just now. I talked about the Snepco job, which was Nigeria. We ran 4 tools for Snepco in 2019, along with Weatherford's TRIP system.
In Asia?
In Asia for Brunei Shell Petroleum. We're discussing their 2021 needs at the moment. Malaysia.
So lots of histories with Shell.
Yeah, one of our bigger customers. Yeah.
Okay. What's the largest casing size for a turbo caser?
At the moment, 9 5/8. Okay. So we can run 9 5/8 casing in 12 1/4 inch hole. We are looking at a 13 3/8 tool, so potentially to come.
Okay. Have we run with sand screens? Lots of times, I know that.
Loads of times, yeah.
Are operators generally reluctant to ream in screens, and why? Well, I'll take that one. So yes, they are reluctant. Absolutely reluctant to ream in screens, and why? And the why is that typically with a wire wrap screen, you've got very close tolerances on the wire, the gauge on the screen, and if you damage that, you're going to produce sand day one, which is going to be a massive problem for the operator. Some operators like to run in sand screens which have got a jacket on the outside, so that it can get a bit more robust. But I don't know any operator who plans to ream sand screen in place because they're just too delicate. A couple of people saying thank you very much. You're welcome.
Steve, sorry, I'm just going to very quickly, I think when you're talking about that, we have run our Turborunner with sand screens. So we ream by way of Turborunner rather than rotating the entire string.
And the next question that comes up with that is always, well, how do you get the flow to the shoe? Because you've got holes in your sand screen, and the answer is a wash pipe.
Inner string, yeah.
Inner string or wash pipe that we
very common. We do it all the time, yeah. And Deep Casing Tools actually own the IP for powering a downhole motor via an inner string. So.
Oh, is that right?
That is right, yeah.
Okay. Okay, a couple more questions, and then there's a question. Well, there's a comment about be good to show animations and explain the difference between Turborunner or Caser. Yeah, we could do that, but they are available on the website. Again, deepcasingtools.com, which is accessible. There's lots of different videos on there which explains what we do. Where are you placing your R&D spend for future innovation?
It's a good question. So I guess it goes back to when Steve, when you and I took over the company, the running of the business 2-3 years ago. The P&A space is somewhere where we're focusing. We have a new tool called the Casing Cement Breaker, which is a very, very novel tool that breaks down the structure of cement and the bond between cement and a casing, make it easier to perf and wash, easier to pull. We're working on that tool. We've done one field trial to date and are looking for further field trials at the moment. Latest generation tools ready to go again. We've also designed a tool called Self-Lock, which is a flotation device for the US land market. Rather than a sub that screws into a string, it's a self-anchoring plug that sits in the tool. So they are the two main areas, while looking at other sizes of turbo caser. That's the three things we're doing just now, really. We have also developed of late, and are about to run for the very first time, our Mech-Lock drill pipe swivel. So we spent quite a lot of time and money on that over the last couple of years. So it's a mechanical drill pipe swivel to allow you to rotate above a liner system and push tools to depth. So it's on a rig site with OMV in New Zealand about to be run over the next couple of weeks. So that's
okay.
Commercial.
Good. There's a question: would it be possible to run a 9 5/8 turbo caser to run a 10 3/4 inch casing, where the next portion of hole will use an 8.5 bit? Yes. So you just need a crossover, right?
That's it. Yeah, we can put a different size reamer on the turbo caser depending on your hole size that it's running into. We can put a crossover from the 9 5/8 turbo caser to the 10 3/4 casing, and the 9 5/8 turbo caser has an 8.5 inch drift, so you can drill straight ahead with your 8.5 inch bit, no problem.
Yep. Okay, and we'll probably make this the last question, unless I see any more popping up. Can you repeat the cases where it's not? Okay, so there's two parts to the question. Which countries in the Middle East do we run the tools? And can we repeat the cases when it's not possible to rotate from surface, which justifies using a Turborunner?
I guess countries are Saudi Arabia, most common, biggest customer we have. We're currently running tools for ADNOC in the UAE. We've run tools in Iraq. We've run tools in Oman. We've run tools in Kuwait. I would say that's pretty much the Middle East covered. And it's typically
for the Turborunner, right?
Yeah. So I guess two things. One is when you simply cannot rotate the string. So that can be due to torque and drag issues. It can be due to a delicate string or completion or connection torque restrictions, or it could even be due to surface equipment. You might not have a casing drive tool or something on the surface if it's a fairly basic land rig. So in an instance where you cannot rotate the entire string, but you think you're going to have restrictions that will stop the string getting to depth, a Turborunner or turbo caser is the perfect tool, I would say. So and more and more of these wells, as wells get longer and deeper and more challenging, it's becoming more and more common.
And of course, we've already mentioned sand screens, but it's where you have a completion where the components mean you don't want to rotate the completion. So that might be swell packers, it might be sand screens, it might be inflow control devices, it might be something that has got a close clearance with your open hole, and you're just worried that you might cause a problem. So that's the probably the cases where it's not possible to rotate from surface with the completion. But yeah, anywhere you don't want to rotate the completion or the long string or the liner or the intermediate casing, that's where we are. So I think that's it, David. I'm going to say thank you very much for everyone. There's a couple of people who've sent their apologies having to run off slightly earlier, but they've left email addresses to get in touch, which we'll pick up on. Just from me and David, thank you very much for spending your valuable time with us. Hope you enjoyed it. It's our first one. We'll hope to do a few more in the future. Any ideas on subjects that you'd like to see, please let us know. And we'll close it down. Thank you very much.
Thank you very much, all. Take care.